Okay, the back half of workshop number 10 has to do with continuing like we did in problem 3A on the previous sheet. We have a couple of functions here. F of s could be equal to 1 over s cubed, h of s could be 1 over s squared plus 1. And so if we have f of s equal to 1 over s cubed, then its inverse Laplace transform is 1/2 t squared. So we need to know how to do that. You can see that right here. You need to know how to do that. And for h of s equal to 1 over s squared plus 1, we have small h of t equal to sine of t. And so now we have to decide, if we're going backwards, we have the product of Laplace transforms. When we go backwards, we have to do a convolution of 1/2 t squared and sine of t. So that's here what we have here. And we have a choice. Do we want to put the v squared with the t and the sine of t minus v with the sine? Or do we want the other way around? And personally, I think it's a little easier to do this part here because we have a biparts here with a t minus v, invites some mistakes. So I think we need to do the second one, which is right here. And so I'm just going to carry this through to a little ways. We'll have 1/2 0 to t. Remember, we're going to integrate this with respect to v, but I need to square this out. T squared minus 2tv plus v squared sine of v dv. So you'll notice what we have. The first term is 1/2 integral 0 to t of t squared sine of v dv, and that is, okay, so we have t squared over 2, because as far as v is concerned, t is a constant, t squared over 2. And the antiderivative of sine of v is minus the cosine of v, and we're doing that between the limits of 0 and t. So we'll be putting those in. The second one is 1/2 minus 1/2 times 2. We have a t and a v sine v. Again, we take the t out front and we get a minus t and a v sine v, and we have to do a by parts for that. And the last one is 1/2 0 to t of v squared sine of v, and we have to do a by parts for that. When we do all of that and put the upper and the lower limits in, collect like terms, this is what we get. I'm not going to do all the little details there. We can, if you want to figure out, if you have a mistake in there someplace, you can always call in and see where that is. And so now we come to the last problem here, and it is a differential integral differential equation, in other words. And so we start off these, y is the unknown here. So the Laplace transform of small y is capital Y. We'll start with that. Y primed is sy minus y at 0, which is a 1. And so we are going to get sy minus 1 for the y primed right here. I'll just underline that. There's your y primed. This is the convolution of two functions. And its Laplace transform is the product of what we have for those. One of them is e to the v, that's 1 over s minus 1. And one of them is capital Y, which is the unknown. And so we have minus 2y and 1 over s minus 1 for that, because this is the convolution of the two functions. Its Laplace transform is the product of those two. On the right-hand side, this is e to the t times t, and here I have worked it out right there. And so you can see what we have. There's our algebraic equation in capital Y. So I gather like terms and keep them on the left-hand side, like terms in capital Y. So there's sy minus 2 over s minus 1. Put the 1 over here, and here's this term. And then I simplify this, common denominator, simplify this, common denominator again, and this gives us, so we have here, this is factors as s minus 2 times s plus 1. Here's an s minus 1. One of these cancels with that, so we've got 1 left, and there it is. And so now here is the, we need to take the inverse Laplace transform of what we see here. And partial fractions gives us the coefficient over s minus 1 is minus 1/2, over s minus 2 is 2/3, over s plus 1 is 5/6. So now we're taking the inverse Laplace transform of that. That you should find easy. They're all exponentials. Minus 1/2 e to the t for there. 2/3 e to the 2t for that one. 5/6 e to the minus t for there. And there's the solution. So we are finished. Okay.